guys, welcome to B.Tech. Now we are going to discuss 2-watt meter method of power measurement. Okay, this 2-watt meter method can be employed to measure a 3-phase, 3-wire star or delta connected balanced or unbalanced load. In 2-watt meter method, the current coils of wattmeter are connected with any two lines, say R and Y are, and potential coil of each wattmeter is joined across the same line. The third line, that is B, as shown in figure. So here wattmeter 1 I have connected to R phase, wattmeter 2 I have connected to Y phase, and this wattmeter, this is current coil and this is pressure coil. So in this is current coil, this is pressure coil. So current coil is connected to R phase and current coil is connected to respective phases, and pressure coil is connected to the same phase, which is B. Okay, and these are the star connections Z1, Z2, Z3, ER1, EB1, EY1 are the respective phase voltages. Okay, so from this, consider the above figure in which 2-watt meter W1 and W2 are connected. The instantaneous current through the current coil of wattmeter W1 is given as IR, right? So IR is the current in W1 and IY is the current in W2. Okay, so coming to voltage, so wattmeter 1 voltage is nothing but ER1 minus EB1. So wattmeter 1 voltage is nothing but ER1 minus EB1, and coming to power, power is nothing but IR into voltage. So IR into ER1 minus EB1, which is equation 1. So similarly, in W2, current is IY and voltage is EY1 minus EB1. So the power is IY into EY1 minus EB1. That is second equation. So if I add 1 and 2, W1 plus W2, which is IR into ER1 minus EB1 plus IY into EY1 minus EB1. So if I extend this, I am getting ER IR1, IY EY1, IB EB1. Since IR plus IY plus IB equal to 0, so I am getting W1 plus W2 is equal to P, where P is the total power observed in the 3 loads at any instant. Hence, the total instantaneous power observed by the 3 loads Z1, Z2, Z3 are equal to the sum of the power measured by the 2-watt meter methods, which is W1 and W2. So that is how we will calculate power of star connection. Now let us see in method of delta connection. So these are the delta connection. So W1, W2 have connected to R and Y phase. Now, so IR is, if I apply KCL here, IR is nothing but I1 minus I3, which is the current in W1. Similarly, W1 voltage is ERB. Now, power in W1 is nothing but ERB into I1 minus I3, which is equation 3. So from W2, current is IY. IY is nothing but, if I apply KCL here, IY is nothing but I2 minus I1 and voltage is EYB. So the power is, W2 power is EYB into I2 minus I1. So from 3 and 4 equations, if I add these two equations, so which is ERB into I1 minus I3 plus EYB into I2 minus I1. So if I add, I am getting W1 plus W2 is I1 IRY, I2 IYB, I3 EBR. Since my ERY, EYB, EB are equal to 0 in delta connection, that's why I am getting W1 plus W2 is P, where P is the total power observed in the 3 loads at any instant. The power measured by the 2-watt meter at any instant is the instantaneous power observed by the 3 loads connected in 3 phase. In fact, this is a power is a average power drawn by the load, since the wattmeter is the average power because of inertia of their moving system. So wattmeter reads the average power. Okay, so what are the alternate methods of a 3 phase? There is a 3 alternate methods: single wattmeter method, double wattmeter method, and 3 wattmeter method. So we already know that our 3 phase power is equal to V phase I phase cos phi, and in terms of line voltages is equal to root 3 VL cos phi. So from this, so how we calculate by using single wattmeter method? Here only one wattmeter is used for measurement of 3 phase power for circuits with balanced loads, and we have 3 phase power is nothing but 3 into wattmeter reading. Okay, so for the circuit with the unbalanced load, we have 3 phase power is equal to sum of 3 phase readings obtained separately by connecting wattmeter in each of the 3 phases. If the neutral point is not available, which means 3 phase 3 wire systems or circuits, then the artificial neutral is created for the wattmeter connection purpose. Instead, 3 wattmeters can be connected simultaneously to measure the 3-phase power. However, these involves more number of meters to be used for measurement and hence not preferred in practice. So if I use single phase wattmeter method, single wattmeter method, so we required here 3 wattmeter, which means it will increase the number of meters. That's why we are not preferring single wattmeter method. So whereas 2 wattmeter method, just now we discussed. So coming to 2 wattmeter method, the circuit diagram we have shown above for 2 wattmeter method of measurement of 3-phase real power is shown bigger on the figure. The current coil of wattmeters W1 and W2 are inserted respectively in R and Y phases, and phase coil is connected to the same line, which is B phase. Now W1 is equal to, we got VRB as a voltage. So from there W1 is equal to IR and VRB, which is IL cos 30 minus phi. So W2 is equal to IY VYB, which is IL cos 30 plus phi. So if I add these two, W1 plus W2 is equal to root 3 VLIL cos phi, which is 3-phase power. So W1 minus W2 is giving VLIL sin phi. Now from this, if I get tan phi is nothing but sin phi by cos phi, right? So from here, sin phi is nothing but W1 minus W2 divided by VL IL, and cos phi is nothing but W1 plus W2 divided by root 3 VL IL. So VL IL gets cancelled. Now my tan phi is nothing but root 3 into W1 minus W2 by W1 plus W2, right? So this is the tan phi formula, where phi is the lagging power factor angle, and it is noted that the equation 3-phase W1 plus W2 and W1 minus W2 get excited if the load is considered to be a leading power factor. So this is the arrangement of 2 wattmeter method. So wattmeter 1, wattmeter 2, R phase, Y phase, B phase of a star connection. So if I draw the phasor diagram, so this is VR, Vy and Vb. So since currents are lagging, IR, Iy, Ib, if I take the negative of Vb, now this is the negative of Vb. Now resultant of this Vy and minus Vb is nothing but Vyb, and resultant of this Vr and minus Vb is nothing but Vrb. So from there, since my W1 and W2 are depending upon power factor angle and power factor, so let us see how W1 and W2 vary based upon the power factor angle. So here I am considering power factor angle first is 0 degree, 30 degree, 60 degree and greater than 60 degree, which is I think like 90 degree. So now in this case, what is the power factor? So power factor is equal to nothing but cos phi. So cos 0 is nothing but unity power factor. Cos 30 is nothing but 0.866, cos 60 is 0.5, and cos, if angle is greater than 60, then cos greater than 60 is nothing but, which is less than 0.5, which is nearly equal to 0, right? Now, so W1 we got that VLIL cos 30 minus phi, and W2 we got that VLIL cos 30 plus phi. So what are the readings of W1 and W2? So from this, and what is the total wattmeter power, W1 plus W2, so which is root 3 VLIL cos phi. So from this we got that if power factor angle is 0, then I am getting my W1 is root 3 by 2 VLIL, W2 is root 3 by 2 VLIL. In this case, when power factor is 0, power factor angle is 0, so both the wattmeters readings are same, W1 equal to W2. Now power factor angle is 30, so in this case I am getting W1 is VLIL and W2 is VLIL by 2. So in this case I am getting W2 is equal to W1 by 2. Now when power factor angle is 60 degree, so here we are getting root 3 by 2 VLIL as W1, but in W2 it is 0, right? So here W2 reads 0 and W1 alone will act. Now when it is greater than 60 degree, so W1 is nothing but W1 and W2 reads negative value, right? So for taking readings, the PC or CC connection of W2 should be reversed. So one of the, W1 is nothing but minus of W2 in the if the power factor angle is greater than 60. So if I take an example problem, a 3-phase 10 kVA load has a power factor of 0.342. The power is measured by 2-wattmeter method. Find the reading of each wattmeter method when the power factor is lagging and leading. So he has given a 3-phase power which is 10 kVA, which is root 3 VLIL is equal to 10 kVA. So from this I am getting VLIL is 5.7735 kV. If it is a lagging power factor, so my W1 reads VLIL cos 30 minus 5, W2 reads VLIL cos 30 plus 5. So substitute these values, I am getting W1 is equal to 4.42 kilowatt, W2 is equal to minus 1 kilowatt. So for leading power factor, W1 reads VLIL cos 30 plus 5, so it will be minus 1 kilowatt. W2 reads VLIL cos 35, it one reads 4.42 kilowatt. So it can be observed that when the power factor is changed from lagging to leading, the readings of wattmeter W1 W2 gets interchanged, right? Here W1 becomes W2, here W2 becomes W1. So from leading to lagging, wattmeter readings are changed. Okay. Now, so if I take the second problem, a 3-phase 400 volt load has power factor of 0.6 lagging. The 2 wattmeters reads the total input power of 20 kilowatt. I mean W1 plus W2 has given 20 kilowatt. Find the reading of each wattmeter. So we know that W1 plus W2 is 3-phase power, which is 2 kilowatt. So from there he has also given VL is 400 volt and cos phi is 0.6. So from there we know that W1 is equal to VLIL cos 30 minus 5. So substitute the given values. So W1 we know. So we need to calculate W1. So VL is 400 volt. IL is nothing but 48.1125 and cos of 30 minus 5 is 53.13. So if I am getting 17.698 kilowatt. Similarly W2 is I am getting 2.302 kilowatt. So this is how we will calculate the power of by using 2 wattmeter method of a balanced or unbalanced circuits. Thank you.